airplanes come in and the internal combustion engine come in and really transform the transportation landscape. So I listed a few of the things that are happening here, and it's kind of hard to keep track of it all because it's sprawling. First, we've got a whole set of alternative fuels that are coming into regular use. We have battery-powered cars, we have biofuels with ethanol, we have fuel cells that are available now out in California and likely are going to be spreading. Pennsylvania has a particular interest in natural gas because we're a natural gas producer now, and the price of natural gas is very low. And so early in the 20th century, there was this dominance by petroleum-based transportation, with the exception of some fixed rail services that were electric. Now it's kind of wide open, and things are changing in terms of what the future is going to be in terms of the fuels that are used for transportation. Second thing that's changing, and it's kind of happening quietly, is the efficiency of vehicles has been increasing significantly. We've got hybrid vehicles, we've got lower weight, we have the CAFE standards that are driving a regulatory push for higher energy efficiency. It's really making a difference in the sort of resources and emissions that are going on with respect to transportation. Sensing and automation, I mean, it's happening everywhere. We heard about 3D manufacturing. Sensing and automation is making that happen. It's coming into the infrastructure. It's hitting vehicles in a major way. All of you are carrying smartphones, which have more computing power than any computer I used at the beginning of my career. So you're all advanced to supercomputer level for my career. Communications is changing, connectivity. And one of the things that's going on there is there's still kind of debate and dispute over what technology is really going to be used. Cell, dedicated short-range communications, Bluetooth, Wi-Fi. It's carrying out in a number of different modal situations. The other thing that's going on with respect to communications is people are kind of struggling with what's going to be the dominant application in that area. And finally, we're dealing with a wave of data analytics for things like vehicle control, for travel choices. Things like the Uber services are really a child of data analytics. And the freight systems that we were just hearing about, again, data analytics plays a major role in transforming that. So all of these trends are hitting us at the same time. And they're not kind of some future sort of thing. They are really happening right now as we take a look at the transportation scene. With those new technology opportunities, there's kind of these challenges that have been with us for many, many years that still exist. We want to provide mobility services to both the economy and to society, so people can access medical care, can access education, can access freight. We need to reduce costs, we need to reduce energy use, we need to reduce emissions. We want to support economic growth. We talked about Charleston as an area that's growing economically. Improve safety and resilience, provide sustainable funding. And I'll just say a couple of things about these challenges. This is the federal fuel tax revenue for several vehicles that I just selected. And I'd like to, well, I'll tell you the vehicles. The one on the far left for you is the 2012 Ford F-150. So this is the federal fuel tax revenue cents per mile from a Ford F-150 bought in 2012. The next one is the Ford F-150 bought in 2018. And these, by the way, are EPA estimates, so your mileage may differ from the EPA estimates. The next one is the 2012 Prius, and that happens to be the same as the 2018 Prius, so they kind of hit a threshold there. At the far right is the fuel tax revenue cents per mile for a Tesla, okay, a battery electric vehicle, and there's no blue bar there. So there's no revenue coming into the federal coffers. And a couple of things about this. Different vehicles have very different fuel efficiencies and are contributing to the tax revenues in very different fashions. And so there are equity issues associated with how we're funding transportation right at the moment. The other thing that's apparent from this graph is that the amount that people are paying into the federal tax revenues is very low. The fuel tax has not risen at the federal level for several decades. That's not the case in the states, by the way. California, just for example, increased their gas tax. But still, this is the sort of thing that's a challenge for how we're going to fund transportation going forward. The other thing that has happened is that road fatalities started going up again. We've had this long series, this goes from about 1973 up to 2015, where the number of roadway fatalities in the United States has been going down. It started ticking up, and it's now up around 40,000. This happens to be normalized per billion VMT, but the same thing has happened for the raw numbers of fatalities. And there are a lot of reasons for this: excess speed, smartphones that are being used in cars and that type of thing. But it's certainly a certain serious problem. I mean, if we were seeing the same thing in the air service, it would be one plane crash every 3 or 4 days would be 40,000 road fatalities. And I think if that was in the newspaper on a recurring basis, people would be outraged. And I think it's time to be a little bit outraged over 40,000 fatalities every year on the roadway system, and we really need to try and do something about safety. So those are the challenges, and our challenge as transportation professionals is to try and figure out how to best use these technological opportunities to address those various policy and economic and social challenges that I was just talking about. And what we're doing is moving from conventional transportation through on-demand ride sharing that exists now in a lot of places, up to a fully connected and automated transportation system that hopefully will try and solve some of the problems and challenges that we have. And I'd like to mention that this is not just limited to roadway transportation. These transformative technologies and challenges are happening to all modes of transportation simultaneously. So in the air systems, we're investing in what's called the next generation air transportation system, NextGen, so that they're trying to improve how the airspace operates. At the same time, we're seeing all sorts of drones start to come into play, and some of the policy issues associated with how those drones are going to be regulated are still being worked out as we go forward. In rail, automated rail typically goes under the name of positive train control, and that's there's a diagram of the Burlington Northern system, and boy, you could just take out that locomotive and put in a car if you wanted to have a connected car vision. The idea is that the locomotives are connected to central controllers, and they communicate, and you avoid any sorts of collisions that might occur between trains. I have a drone for sale, $90. Well, you can go out and buy your own drone now and operate it. The other thing that's going on with rail is alternative fuels are as much an issue there as they are for light-duty vehicles. So that we are seeing battery electric locomotives and that type of thing start to come into use. Bikes. Bikes sounds like an old-fashioned kind of set of transportation. But the new electric bikes are really technologically sophisticated in terms of their battery and how the gearing works and that type of thing. I was biking over in the Netherlands, and I kept getting passed by these electric bikes, and I said, oh, this is terrible, I'm getting old. And then I realized it was the technology has really improved. And then bike share analytics. Again, the data analytics coming into a mode and really transforming how it works with bike share. Scary one. I talked about kind of conventional modes. The other area in which you're seeing automated vehicles come in is for military vehicles. And so we have this whole generation of unmanned military vehicles. Right now they're drones that are teleoperated, but the next generation is going to be autonomous. And so that's going to be something we'll have to deal with. But transportation, as I said, is changing throughout the modal areas that it operates in. And you know, when you read the press, I talk to the media on a regular basis, and they're always interested in when are we going to get to driverless vehicles? What are the issues associated with driverless vehicles? And one thing I wanted to point out to you in this little study that we did at Carnegie Mellon last year is that we're already seeing impacts of automation in the vehicle fleet. And so the first generation of partial automation is being offered for sale. It's forward collision warning, it's lane departure warning, and it's things like rear collision warnings. And these are becoming more and more common. More and more motor vehicle manufacturers are offering them as options or making them standard in their fleet. And the little study that I worked on with Corey Harper, who's way on the left there and was a doctoral student, myself and my colleague Costas Emeritus, is to ask the question, is fleet-wide adoption of this partial automation technology worthwhile? And we took a look at insurance data from the Insurance Institute for Highway Safety, and they provided us with what was the change in crash frequency for vehicles that were equipped with these early generation warning devices versus those that weren't. And then we looked at kind of the crash data associated with lane departures, forward collision, and that sort of thing that's got compiled by the federal government. And we wanted to know what were the costs and benefits of this early automation features. And by the way, I can tell you that the crash reduction was very small. When we did this, it was a little over 1%. It's crept up to about 1.4% or so. But crashes are so expensive that, let me give you the figures. Sorry. Observed crash frequency reduction is small, 1%, 2%, somewhere in that range. But we all believe that those first generation systems are going to get a lot better as the motor vehicle manufacturers work out how to do human-computer interaction better. The big change, I think, is that forward collision systems have gone from just making a warning to you to actually braking. How many of you have forward collision warning systems? Okay, a few. Good for you. By the way, I should mention that these early generation partial automation systems are subject to all the rebound effects that we have. When seat belts and airbags came in, you could go out and look and see that drivers were less risk averse. They were relying on their technology. And I think the same thing is probably happening with these warning systems. Drivers are probably paying less attention to driving and relying on these systems so that you're not getting as much of a benefit as you would if they were still doing the same sort of driving they did before the warning systems came in place. Good news is the rebound effect usually isn't 100%, some fraction. So this is all crashes 2012. Only 5% of them involve blind spot monitoring, 6% lane departure warning, 14% forward collision warning. But still, that's a lot of crashes. We have a lot of crashes in the United States, and even when you look at fatalities, we're still talking 10,000 people associated with these warning systems, and if they were completely effective, which they're not, you would have a major change in the sort of fatality rate. By the way, interestingly enough, the fatalities in the U.S. are kind of concentrated in the central portion of the country, and so fatalities avoided per 100,000 drivers with these warning technologies really will help some rural areas. So we took a look at the cost. The cost would be the cost of equipping the entire fleet with these warning technologies. The benefits are that 1-2% reduction in crash frequency and also a little bit of a reduction in the severity of crashes. And what we found was that the benefits are something on the order of $17 billion if the whole fleet was equipped with these partial automation warning devices. The costs were less than that. and the difference, the net benefit, was about $4 billion to society. So if we equip the entire vehicle fleet, which isn't going to happen, but it'd be nice to have it, we would save $4 billion a year for these partial automation things. And $4 billion is an appreciable sum of money. If we could get these early generation warning devices to actually avoid all the crashes associated with forward collision, lane departure, and that sort of thing, suddenly you got $200 billion of annual savings. And so we as transportation professionals, the challenge we have is to try and get these sorts of technologies out there and really make them effective, more effective than the first generation systems. So that's kind of arguing that we're already seeing a little bit of benefit from automation, a little bit of benefit from a lot of these transformative technologies. Well, maybe more than a little when you think about the impact Uber and Lyft and things have had. But we need to really build on kind of the development of these technologies and the opportunities. I might mention that the transformative technologies have been decades of development. Biggest thing was the Moore's Law. You all probably heard about Moore's Law. You pack in more transistors onto a chip, and the scale here on the vertical axis is log, and the scale on the horizontal axis is years, and you can see that the computing power on a chip has just gotten dramatically better than it had been, and that's really one of the things that's driving these transformative technologies that we have. And I'll give you a little history. So I've been watching automated vehicle research at Carnegie Mellon for more than 30 years. And this is a little poster that was put together to celebrate 30 years of automated car research at Carnegie Mellon. And it starts up the top, 1984. That big blue box is an early generation LiDAR. So a laser ranging system. Now they're a lot smaller than that old box. The Interrogator is the name of the device up on the top right. It was like a small table with 6 wheels. It was originally developed to be teleoperated and to go in and do reconnaissance in the 3 Mile Island reactor chamber. And it actually did that. But only one of the Interrogators went in, and they made about 5 copies of the Interrogator, so they had stuff to experiment and that sort of thing. And somebody was smart and said, gee, those excess Interrogators could be used for autonomous vehicle research. And so that was the start of our automated vehicle research back in the early 80s. By the way, the Interrogator, when it was in autonomous mode, traveled slower than you could walk. Now, and I'll give you another story. It was programmed to follow straight lines, straight paths and roads and that sort of thing. And it, one of the test places that it went to was the park right beside Carnegie Mellon, which had curving paths. Well, an early generation of the Interrogator spotted a tree and decided to climb the tree because it was straight. Technology's improved since that time. NavLab was the second one down there. It could go at about 6 miles per hour, or 8 miles per hour, something like that. Next generation is actually still in use, the Jeep. We still use it as a sensor platform around Pittsburgh. BOSS is the one right here. BOSS was the vehicle that won DARPA's Urban Challenge back in 2007. And that was a major milestone for automated vehicle research. You had dozens of teams that were competing in an urban environment, and the idea was to have the automated vehicle run a course, and you had to obey all the traffic laws. You had different tests and obstacles you had to get around. And it was a demonstration that driverless vehicles were actually possible and were going to be here sometime in the future. So big deal, 2007. By the way, 2007 marks the time where you suddenly started to see a lot of manufacturing companies and software companies really ramp up their research. And so it started to move out of kind of university labs into the private domain after that demonstration. By the way, I should mention, BOSS was completely autonomous, no connectivity. That was the rules of the urban challenge. The next generation is down below with my colleague Raj Kumar, and that's his Cadillac, where he had the challenge of trying to make it look like a regular vehicle. So he embedded all the sensors into the Cadillac and embedded the computing into the trunk. So BOSS is on the left, the Cadillac is on the right, and you can see it just looks like a regular Cadillac. You can see there are some sensors that appear, but it's not very apparent. And that's probably going to be the future of what automated vehicles look like. By the way, the Cadillac is both connected and automated. So the Cadillac has the capability of dedicated short-range communication with traffic signals in order to tell where the traffic, what phase the traffic signal is in, which is better than just relying on video the way BOSS did. I mentioned computing. This is just an illustration of the different generations. BOSS is on the left, and the computing for the Cadillac is now down where the spare tire typically is in a Cadillac. So that's an example. Lots of challenges for the students out in the audience associated with these autonomous vehicles. Technology has got to be made, reliability, cybersecurity is an issue, range of use is an issue, what sort of characteristics. I think I have a slide on that coming up. User acceptance. I suspect that people will end up accepting these things as long as they feel safe, as long as they feel it's reliable. Policy. Lots of debates in Washington and in the States about what should be policy towards introducing these vehicles over time. And different implementation horizons. Connectivity is coming pretty slowly. Automation is coming really very quickly. I talked about range of experience. So September, right after Labor Day, I took a trip to Yellowstone National Park. This is Yellowstone National Park. Lots of buffalo. We got a foot of snow while I was in Yellowstone National Park, and so a lot of the buffalo came down. And I was driving around with a rental car that had adaptive cruise control. And of course, a forward collision warning system and a braking system. And so I'm driving around Yellowstone in the snow, and every 20 minutes I've got to pull aside, pull over to the side. Anybody? I'll tell you. The radar system was behind the emblem of the car, and it kept getting water on it. So I'd hop out of the car, clean off the emblem, the adaptive cruise control would start working again, off I'd go again. So that's the sort of challenge that exists with respect to range of use of these technologies. And of course, with snow and car emblem, of course, you're getting water kicked up onto the emblem all the time as you're going along. It's probably less of a problem if you've got the sensors up on top of the vehicle than with my car that was driving around. Lots of challenges for infrastructure. Many of the software systems that exist for automated vehicles take advantage of lane markings, and so there's a challenge in making lane markings really useful. By the way, I went to Beijing, and there's a lot of interest in automated vehicles in Beijing, and I kept thinking to myself, they're going to have to completely change the software paradigm for a lot of the vehicles that exist right now. Because if you drive around Beijing, you realize that nobody stays in their lane. I mean, there's not good lane discipline, and a lot of the software that exists for things like the Tesla is assuming lane discipline. The other thing that's going on with automated vehicles is that there are these competing business models, and you can read about them in the press all the time. There's the idea of driverless taxis. So we have about 30, 40 Uber automated vehicles driving around Pittsburgh on a regular basis and giving rides to people. They're not completely driverless. There's somebody sitting in the front seat, actually two people sitting in the front seat. But clearly the idea that Uber has over time is to go to driverless taxi types of services. There are driverless shared ride vehicles. Transit agencies are interested in this. Mobility suppliers are interested in this. If anybody noticed in the media, there was a shuttle service in Las Vegas that's been operating that's driverless. There's privately owned, partially to fully automated vehicles. The vehicle manufacturers are offering those. Technology adopters are interested in making those available. Continental, Delphi, those sorts of people. And then there's a whole series of business models where they're targeting connected vehicles with some sort of manual driving. And those could be bikes, cars, trucks, and the connection could be built into the vehicle or it could be through a smartphone. And the business model that's being pursued there is telecommunications suppliers and software companies. And the interesting thing right now is nobody's quite sure how these business models will play out in the marketplace. And we'll just have to see what happens over the next couple of decades in terms of which one ends up being more dominant than the others. My guess is, by the way, that you're going to see a lot of these in play over the next couple of decades. All right, I talked about in-vehicle automation technology already, so that gives you some flavor of what we've been doing at Carnegie Mellon. I'll talk a little bit about automated vehicle and infrastructure policy, since that's kind of interesting, I think, for DOT people. I know that you guys have a bunch of traffic signal work going on, so I thought I pulled out an adaptive signals example. And I'll talk a little bit about a new initiative we have on smart mobility, and that'll be my conclusion. Just to give you an idea of how we're organized, the Traffic21 Institute is cross-campus. We manage it jointly with our university transportation centers. We have a National Center for Safety, National Center for Smart Mobility. Traffic21 has been around for a while, and it works through partnerships with Pittsburgh and Allegheny County and Pennsylvania and private companies, and it deploys technology. And it's been fairly successful, and so we decided, let's do a startup, Metro 21, which will do all urban systems. So we've got this startup that's operating in parallel with Traffic21. By the way, one thing that we do for our national centers is have a summit every year. And if anybody's interested in safety or smart mobility, you're certainly welcome to attend our summit. We started off having them in Pittsburgh, and then we moved them to Washington, D.C., so we could get people from the Hill and people from the agencies. The smart mobility one is going to be in March. So if you're interested in that, talk to me. And then Traffic21 Institute, we tend to work through a lot of special interest groups and research programs. So we have a special interest group in ride sharing, bicycling, connected and automated vehicle policy, lots of things like that. And I encourage you folks to try and form up those special interest groups within the different research areas that you're working on. One of the early policy studies we did on automation was what was called Vision 2040. What does PennDOT have to do to change to become ready for the automated vehicle of the future? And so these are the near-term recommendations we have. Evaluate plan capacity enhancements. We have a lot of kind of local planning agencies that would love to see major capacity expanses to the Pennsylvania roadway facilities. So for example, in Philadelphia, the Schuylkill Expressway is a very congested roadway that they'd like to see expanded, and it would be very, very expensive to try and do that. One of the things we said is that platooning, smaller vehicles, might make those capacity expansions not as beneficial as they might look with new technology. Collaborate with the private sector to convert data into information. A lot of DOTs collect a lot of information and tend to try and hold it as close as they can to themselves rather than making it available to the traveling public on a regular basis. Begin deployment of vehicle to infrastructure applications. As you're renovating traffic signals, it is cheap to put in dedicated short-range communication capability. And so there's no reason not to do that because you know it's going to be needed sometime in the future. Eventually, we're going to have to start worrying about changing driver licensing rules, platooning. Platooning actually is coming pretty quickly. We have it listed as 2021, 2030. We think that the Ohio Turnpike is going to do platooning demonstrations this coming summer. And then in the long person, there's possibilities for reconfiguring and repurposing lanes. I talked about the capacity changes that might be possible. Provide for a new license class for those wishing to drive their cars manually. Eventually, you're going to reach that stage where there's a whole bunch of driverless vehicles, but there's still going to be old timers who want to drive their car. And so you're going to have to figure out when that might be allowed. I thought I'd say a couple of words about adaptive traffic signals because I know a number of you are interested in that. We have a group in robotics who's been working on adaptive signals. Their approach is disaggregate. They have controllers that act independently to make phasing decisions. The controllers intercommunicate so they can report on what they're going to be doing in terms of signals and what's coming along. Our system, which is about 50 intersections right now, uses video identification of vehicles. The group is working on video identification of pedestrians. So instead of just using a button to indicate when a pedestrian wants to cross, do a video identification and also have an identification of when people are still in the crosswalk. And of course, communication with transit buses and trucks, I think eventually will happen, but we're starting with transit buses. And eventually, I already mentioned this, communicate with pedestrians in all vehicles. And for those of you who don't know about adaptive traffic signals, I'm a big fan of them because I look at intersections like this and I say, this is a waste of resources. Okay, you got a green light going this way, no traffic, you got cars queuing up, you've got no pedestrians. What that traffic signal should do is switch over its phase and let those queued up cars start moving. That's adaptive traffic controls. And it's the sort of thing that I think will be the future. We've seen in kind of the 50 intersections that we put in the adaptive traffic signals with SurTrack that the travel time has dropped, the number of stops have dropped, the wait time has dropped, the emissions have dropped. What hasn't increased is the speed. So the average speed through the network has gone up, but the maximum speed is not going up. So it's mainly just the number of stops that you have to make. And this is the video on the left. The cabinet starts getting really crowded because you've got computers for the video identification, you got videos for the adaptive signal controller, you got videos for boards for communication. So it is more expensive and it's a capital cost to begin with, but I think the efficiency will cover the cost over time. Thought I'd just mention we have a new initiative on smart mobility. We've primarily been working with Pittsburgh and Philadelphia in terms of technology deployments. And we decided that what we really wanted to do was start working with some rural areas. So we got funding from the Hillman Foundation, and we're partnering with 9 municipalities to work on changes to their parking operations, ride-sharing apps, safety improvements. And we think that's something that will really pay off to have partnerships with kind of rural communities. We also have a new project starting off in which we're trying to put like 8 different smart mobility solutions into a network area and see what the effect, what the synergies might be between all those different things. It's called the Forbes Avenue reconfiguration. Got $4 million to do it. We've got an assessment project going on. That'll be, results will be coming out next year. Again, it's the sort of thing that I think really illustrates these technologies and what they might be doing. That's all I got. I got you closer to schedule, and I have time for a few questions.
Thank you. So I would like to comment and we'll then take questions. So Dr. Chris Hendrickson has been my idol for many, many years. So we didn't, if we started talking about what he has done, it would take the half of our conference time. So he is a National Academy of Engineering member. And he has done so many things. So there's this cost analysis, the life cycle cost. The tool that we all use was developed by Dr. Hendrickson. So yeah, we are just so fortunate to have Dr. Hendrickson as our distinguished speaker. So please, feel free to ask questions. Yeah, thank you.
Yeah.
I'm David Jarrett with the Georgia DOT, and I just want to compliment you on the work that Carnegie Mellon has done. I had the privilege of riding in that Cadillac in Buffalo.
Good for you.
So, yeah, it was amazing to see the car actually perform the turn all by itself. So I've had some experience in riding in a driverless car. So.
By the way, if anyone's interested, you can Google on YouTube and you'll see trips with the car. Maybe you're on YouTube.
Yeah, I could be and not know it. But Raj did take us around about a mile loop, and it was very nice. And so the work that Carnegie Mellon is very consistent with what we're trying to do in our state. We've just launched something similar to Vision 2040. We're contracting with Georgia Tech on sort of a outlook for autonomous vehicles, a roadmap for the research that we need to do, preparations we need to make for the advent of driverless vehicles in our state. Also, you mentioned V2I. I know that's the direction our CEO would like to go in the near term with some implementation. So that's consistent with what we're doing. I was really impressed about the cost analysis you've done for the first round of the early stages of automations. Does Carnegie Mellon have any plans for doing similar studies as the technology progresses? Because I would encourage you to think along those lines, and the other schools here as well, because that's great and that's very useful. I plan to take that back and notify our in-state partners about that work that you've already done. But I would guess you may be thinking along those lines that as things progress, you want to do it in stages, analyzing the benefits that you're realizing.
No, I do want to revisit that particular issue. And what we've seen, I had a student looking at the numbers, and we may come out with a paper on the topic. The crash frequency has continued to improve. I mean, those first generation systems are actually getting better as we expected. And I think the big change is going to come with the active forward collision avoidance and the active back collision. And so I'm eager to get those numbers, but we're not going to see them for a couple of years because they're just appearing. The cars are just coming out, and so we've got to get some experience on the road.
Right.
You can simulate, you can forecast, but it's nice to have real empirical data about how they're performing on the road. So that's something, yes, it's on my agenda to keep an eye on. Yeah?
Two questions. One regarding lane markings. So you mentioned that autonomous vehicles could make better use of lane markings. So since the control can be pretty precise, right? Do you see it being smaller? Because that's one way to increase capacity, for example, on Schuylkill Expressway. Do you see that being happening from 12 feet on a freeway, for example, down to Mars 10?
Yeah, I do. And in fact, you might think about header. The question, do we see lane markings getting narrower over time? And let me do a two-part answer to that. One of the debates going on in kind of the automated vehicle world, software world, is how much you depend on lane markings and how much you depend simply on location and mapping sorts of things. And my feeling on that is the more sources of information you got, the better. That's why I like the Cadillac being able to get the DSRC communication with the traffic signals, in addition to having video connection. So having mapping and having lane markings is really, I think, helpful. Will we see narrower lane markings in the future? My guess is yes, but it's going to be a long time. And in fact, you may see lanes that are restricted to very small vehicles sometime in the future. I can see that happening. Small vehicles, of course, the public perception is they're not as safe. If the automated technology really gets to be reliable, then those small vehicles can be just as safe, and then you can go to much smaller lane markings. The most interesting case, I think, in the near term right now is what's going to happen with work zones, which are often more confined than kind of the conventional lane marking. And you'd like to have kind of the partial automation systems, and then as automation progresses, those become safer over time for trucks going through and buses going through and that type of thing.
Yeah, my second question was, so I hear stories, and I have a friend, Mike Hunter from Georgia Tech. He gave this presentation, and he was giving an example in the future where he could foresee us going to the office and just tell our car, okay, go to this, satellite parking lot, come back, pick up at 5. How feasible from your work is?
Yes.
I see.
I mean, as soon as you get driverless vehicles,
You can.
it's going to be cheaper if you want to drive to your workplace to send your vehicle out to free parking somewhere. And the Cadillac that you were mentioning, we've demonstrated driverless free parking or parking on a parking lot on Carnegie Mellon without even anybody behind the wheel. So it's coming. The interesting thing there, though, is that you drive in, you go into your workplace, and the question for you is, do you take your private car and send it up to do free parking, or do you tell it to go and start doing Uber-type service? And you'll have to make that decision. Yeah.
And just to add on to that, because with this automated vehicle and the traffic problems we have downtowns right now, and parking is being an issue, and so you can get dropped off at work. But now then you have 2 trips instead of 1 in both the morning and afternoon as your vehicle drops you off. And no problem, they can sit in traffic all day, but they're going to be interacting with other folks and causing issues with other folks that are driving their vehicles.
Yeah.
So I guess do you have comments on that? Because I know that's a big issue.
Sure. Yeah, I'd like to see him pay for coming in as a single occupant in his vehicle, as a toll sort of thing. And so those who came in with a shared ride sort of service wouldn't be hit with the same sort of charge. That's one way of going about it. Another way is just straight regulation, of course. And the third way is just to live with the congestion. So what you'd like is to encourage some sort of shared ride or alternative mode. I'm an example of that. I walk to work. So I'm all in favor of bikes or walking. Yeah.
Can you comment on the Uber experience in Pittsburgh and what the prospects are for automation locally?
Uber's done pretty well in Pittsburgh. They've had like one fender bender, and it was kind of the fault of the other vehicle. They are really prominent around town. I mean, I walk into work and I'll see an Uber vehicle most days going around. So they kind of are all over my area of Pittsburgh. When is that going to translate into driverless operation? I don't know. There are some real policy issues associated with that. Reliability, I kind of mentioned the extreme weather that might have impacted those types of services, and so all of that is being worked out, and there's a lot of money being poured into it right now. So Ford and GM have talked about having driverless fleet operations operational by 2020. And
And that's about as good a number as I can give you. I don't know, Uber is very close mouth. They haven't said that sort of time schedule. But they're clearly spending a lot of money doing development.
So I'm going to stand again because I'd like for everybody to hear this. Number one, I want to say thank you for coming. Thank you for being a leader in transportation for a long time, because I'm guessing those 25 years or 30 years celebration, that was 2014 or 2016,
Yeah.
Observe 2012, so you were part of all of that. So thank you for that leadership. CMU has done a tremendous job. And so thank you for coming. I hope that we're going to be able to engage with you, Clemson, and this group here today. I want to just touch on an email that I forwarded to some of my colleagues in Greenville that came, it was back in July. It came from your colleague up there who runs Trans21 for you, and I had it here for you.
That's Dan Caldwell.
I'm sorry, Courtney Area.
Yep.
And what it was, it just happened to be the challenge deadline for the Traffic21 Mobility 21 Sport Mobility Challenge.
That's what I was talking about.
That's what you're talking about.
Yeah.
So in May, I had been in Pittsburgh for a NACO, National Association of Counties, peer exchange where we were looking at autonomous vehicles and the opportunities and this kind of thing. Visited CMU, saw that Cadillac down in the basement or wherever. Phenomenal. So I sent an email to my colleagues saying, what's the potential for us, Greenville, Clemson, to do something like that? And my colleague Fred Cartwright said, Fred, we have the makings of something similar between a UTC, Beyond Traffic 2045 with Ronnie Chowdhury, can comment on these, but most importantly now, a transportation forum being developed for October, which we've already just had. Note that the intent of step one of the CMU Traffic 21 initiative below was to have this transportation conference or summit like we just had. So, and then Ronnie responded saying, CMU is using their UTC as an enabler. I will be excited to move on toward a similar collaboration model. So Ronnie's looking forward, that was back in July, to this kind of event. He probably knew that you were coming and this was happening. So it's coming together. So here's what I want to say as a county council member in Greenville, South Carolina. How can Greenville, the county of Greenville, the city of Greenville, Clemson University International Center for Automotive Research, Fred Cartwright here, how can we collaborate with you and CMU and the city of Pittsburgh, the county of Allegheny, to move this autonomous, connected, electric, shared vehicles forward?
Yeah. Well, I mentioned one forum that's important for us, and that's the summit that we organize. That'll be in March for smart mobility. And that's going to be a major event for that type of interchange. That'll be in DC, you know. And basically, we invite all the UTCs to participate in that who are interested in that topic. So in the past, we've been doing safety because we've had the National Safety Summit. This one's going to be smart mobility, and so we're going to contact all the UTCs. In fact, I think we already have.
Right.
To participate. And that's a good time for that sort of conversation to take place. Any other questions?
Quickly, one quick one, please. I do. Let me stand up. Chris, first, let me commend you for a very powerful presentation. So I really appreciate that. And I like how, basically, you started with the genesis of transportation and come back to where we are today. So as you know, historically, civil engineers are considered the unofficial custodian of transportation. And of course, you're a civil engineer, and most of us we are civil engineering. But given the paradigm shift in transportation of technology and related areas, what do you think? What would be a typical profile of the new generation of transportation engineering?
That's a great question. So in our Traffic21 Institute, in terms of the funding profile that we have, we're funding more projects with faculty in computer science than anywhere else on campus. And so these are people in robotics, in human-computer interfaces, in information systems, that type of thing. So that kind of shows you where the technological opportunities are. So what we have to do as civil engineers is make sure we've got a place at the table with those technologies. So you just have to keep developing new skill sets as you're going along through your career. And I've had to do this numerous times over the course of my career, where I had to sit down and start learning a new field. And that's what we have to do, and we have to bring those new fields into the curriculum on a regular basis. So, for example, Ronnie's teaching a course in data analytics. We're teaching a course in data analytics. 10 years ago, that would not have been in the curriculum of civil engineering. Now it is, and it should be. So that's what's going to have to happen in order to have the civil engineers have a place at the table for transportation engineering in the future.
Great answer.
Okay. Thank you.
I think this is an important area. So, Tonya, I think that we need now, so we have this boundary, civil engineering, mechanical, computer science, but I see the future will have cyber physical systems engineers. So I wrote a paper, I did some research on it. So for future, I think it's not only civil, we will not be called civil engineers or mechanical. I see cyber physical systems engineers. So I think that's where I see future is going. So you need to know a lot of different things, not only one area. Because structural engineering, for example, in civil, so most of the things they are doing is through health monitoring, right? So we are using sensors, and then we are using data analytics to identify what is the problem and the bridge. Before, we used to send technicians to look at the bridge, but that's very it's very costly, and you have to, and also it's very difficult sometimes to find out what's going on inside the bridge. So we have this automated inspection. So very soon we'll go towards that, having these cyber physical systems embedded in everything that we do. So I think we need a new breed of engineers.
Are we going to be replaced by autonomous professors?
But they call you the autonomous professor anyway, right? So,
I will.
yeah. So show your robotics dance. It's a very important robotic dancer. So we'll have a short break now for 10 minutes, and then we'll come back and. Okay, so we have some posters outside from different partner institutions, so feel free to see those, and we have some students standing there.